Okay, guys. So welcome back in our somewhat bi-monthly, probably, Rust and C++ Cardiff, or at least last one was 2 months ago. Not sure about the last but one. But anyway, it's nice to see more people, probably. Hopefully it's gonna get more and more as we progress. Yeah. Oh, how do I change those slides? So we're Rust C++ Cardiff. You can see our Twitter handle. You can see our email address, which got corrected. So now you can contact us by Gmail, which is cool. Nice. So yeah, as normal, our objectives are to learn and share. Obviously, even if we know something, we still learn if we're teaching other people. And then obviously also other people know some things better than us. So hopefully sharing is working for both ways. Hopefully we'll find new people here, new friends, new colleagues, and so on. Yeah, let's challenge ourselves with the things we don't know and just learn them together. Hopefully we'll find some real-world solutions together and we advance our abilities. Cool. So well, it's worth mentioning our sponsor, which is Esri, a very great company. So some time ago, I listened to the software engineering radio podcast with the guy working for Esri, and I didn't know that they're making so many things. So it's worth watching, guys. Really, or listening to. Yeah, we have a short code of conduct. So basically, we worry about our privacy and your privacy. The code of conduct is just be wonderful to each other, and then we have a Pacman rule, which means we eat each other's brains, or we invite everyone to join whatever discussion we're having. Yeah, so the agenda for today is Chris is gonna show us some web server on Raspberry Pi, and then Roy Barken, hello, he's gonna give us some taster of his talk he's gonna be having soon about type traits, concepts, and specializations. Oh, Krzysztof is not gonna have a talk. He's a disappointment. Then we'll have some chit chat break, and then Richard, which will show us some stuff about variants and compare them to Rust enums. And Ciara at the end will show us about things about the tail recursion. Yeah, so I think now it's time to give the microphone to Chris, and hopefully you'll enjoy.
Thanks for handing me the microphone, Krzysztof. It's been a while since I've spoken or seen any of you, so this is quite fun, isn't it? Right? Yeah, fun. No, Krzysztof, why aren't you doing a talk this evening?
Yeah, it's complicated.
Okay.
Sorry guys. Yeah, I just didn't manage in time, unfortunately. Right? I just dived too deep and got myself into troubles. So I just didn't finish my talk, unfortunately. But that means there will be one next time, right? About modules.
That's quite all right. If you would stop sharing your screen, then I can share my screen.
Okay. Yeah.
Unless I can request control. I don't know how this. No, I have forgotten how to use Zoom. Right. So I can see everybody can see that. So, okay, just a quick background of myself, if you don't know who I am. I kind of cut my teeth in the games industry, particularly in the indie game scene for quite a few years. I've got quite a lot of interest in graphics programming and audio programming. Now I kind of work for Esri, doing some of that things, you could say. So based in Cardiff. I'm one of the research and development officers. So that's my Twitter handle if you want to follow me talk about just random stuff and have actually nothing productive to say at all. So today, as Krzysztof was saying, I'm kind of talked about getting a web server working on a Raspberry Pi. So really, this is a kind of talk about how I learned how to use Rocket.rs, Rocket.rs to build an image board. So there is a reason why I'm kind of doing this. So I wanted to build, I want to build a web app for a project, and I don't really have an experience in building web apps. I've done quite a few kind of front end stuff with web, so like just websites and, you know, like JavaScript, but I haven't really got behind the back end onto the server side. So I kind of started looking around at different approaches. So it seems to be the common approaches are kind of using Apache or ASP, I think. I'm not really entirely sure because it's a Windows kind of product. And I've heard that it's not probably the best thing. You want to keep it kind of Linux-based or Unix-based. So the fashionable options, you know, is to use languages which I'm interested in, which is C++ and Rust. And on C++ side, there seems to be micro WebSockets, which apparently is quite good. I haven't used it. Does anybody vouch for micro WebSockets or any other web server library on C++?
I think there is WebKit, or I
Okay.
forgot how it's called. Yeah.
Okay, thanks.
Which is pretty popular.
Thanks. And on the Rust side, there's Rocket RS, which is what I saw looked pretty good. So that's kind of what I'm just going to be kind of showing you today. Oh, sorry, I am not used to presenting. Right, so so objectives of this project is to build a user-driven web app. What do I mean by that? So it's a web page where you can upload files, upload and store those items. So there's media. So you got text and image. That's the only thing I was particularly interested in. Both of them present different challenges. Dynamic page generation. So creating a kind of like an image board kind of presents the best scope of doing this. So you upload an image, upload some text, and then you want to see that page change for others. I also want to make this publicly accessible as well. So I wanted to make sure that other people could join and also post. So this is going to be an interesting test tonight to see if any of you can join the page and post your images or text. I will be keeping a close eye on TTP. So if you don't know what that is, I suggest you kind of check out what TTP stands for. And I wanted to use my Raspberry Pi as a server. So those are kind of the objectives of this project, and I've kind of met them all, I think. Being publicly accessible, I think, is going to be a test tonight. So here's the setup that I'm running with. You need a platform that compiles Rust. So I'm using a Raspberry Pi. I just have to make a quick note here about use versus resources. So like a Raspberry Pi isn't the fastest machine in the world. And if you're doing quite a lot of computing on it and you're handling quite a lot of requests, it's going to fall apart pretty quickly. So if you do want to do something, you want to do something scalable, which is where those servers come in, those big meaty servers come in. You also need to use Rust nightly, and you need to forward your ports correctly on the router. Default is 8000 with Rocket RS. So those are just kind of like some gotchas, just be careful of. Right, okay, so this is the IP address and the port number of the web page, which is currently running on my Raspberry Pi. If somebody wants to copy that and put it into the chat, I would be grateful, because I'm going to go over to the page now. So this is the page that I currently got. Now, I'm not really going to talk about like the HTML front end. I'm not going to talk about the style or anything like that, because it's not really what the focus of the talk is. If anybody wants to give me a style sheet this evening, which is better, then please feel free to do so. So what we got here, we just got a simple image board, really. So you just type in your message, like hello world, of course, and then we can just post that, and then.
Yes. I think you're sharing your slides and not your screen.
Oh, thank you. I don't know what's going on there. Okay, right. Let me change that. Cool. Is that better?
Yeah.
Oh, hang on. Uh-oh. Has it all gone wrong? No, it hasn't gone wrong. It's just being slow for some reason. Oh, it's probably because I'm using Zoom. So there you go. So I'm not on the best internet either. So this is the, so I just made this post here. You can see that the page has been updated with that. So if anybody wants to, feel free to post your own images and your own text. We will keep an eye on that over the evening and seeing if it stands up to use. There is a couple of things, a couple of limitations that I want to talk about, which I think is where it could fall over. But we will get cross that bridge when we come to look at that code. So has that been posted in the chat?
Yeah, and upload something. Are you compressing the images, by the way? Because I just realised I uploaded a massive image.
No. All those images are coming in raw. Yeah, all those images are coming in. Oh, good grief. Right. Okay. Well, it looks like it is working. Is this the image that you posted, Ciara?
Yeah, I just had it. It's one of the machines. So sorry.
It looks like a big one. It's going to take a while, but okay, cool. So if we just come back, okay. So let's go and look at the code. Let's see how this is kind of implemented here. So this is the console on the Raspberry Pi. So I've SSH into my Raspberry Pi, as you can see up here. And I'm running the Raspberry Pi, and it's giving us back messages of it running, and there's a lot of 404s here which are related to the favorite icon, the fav icon. I haven't included, so that's where their 404s coming from. No idea what this is. Failed to write response, code 32, broken pipe. Suggests that maybe somebody was trying to upload and then they refreshed a page during that time. So that's quite interesting as well. Okay, well, let's kind of have a look at what we've got here. So, okay. So let's have a quick look at the cargo tumble first. So I am not using them much really. So I'm using Rocket 4.5, 0.45. And the way that Rocket is designed is for it to be more of a framework that's quite modular, and therefore it's kind of missing quite a lot of features. So you need to go to other people kind of fill in those feature requirements. So we've got a Rocket multi-part form data, which I'll go into, and Rocket contrib, which is official contributions which Rockets approve of. And we need that to get at static files, which I'll go to in a minute. Okay, so let's actually look at the code itself. So what we're doing here is we've got a function which is start Rocket. I have to say that the examples and the documentation for Rocket are amazing. So it's a really good place to start. Probably took about 8 hours worth of work to do all this. So the first thing that you kind of notice is that it's got this idea of mounting. So Rocket is kind of based on this idea of kind of routing kind of web requests around to functions in the code. And it based it quite a lot on macros. The challenge though with macros is that, yes, it can be quite easy to use, but you need to understand the language that you're kind of creating with it. So we've got two mounts. We've got to our root, our web root. So we've got these routes, which is index, which is the first page which you land on when you go to the IP address. And we've got message post, which is the post command from the form. We've also got static files as well, which is required in order to link the style sheets and to the images together on the HTML page. So, right, as we got here, we got index. So the first route that it looks at is index. So when a request is for just the site root, which is /, I have to preface this, I'm not an expert in web development or server-side stuff. This is just stuff that I've learned. So if there's anybody out there who can correct me, then please do. And all that is doing is getting the board page, which is the function above, and it's returning that as a HTML type with a string inside. And that gives us our HTML page for our browser to generate. So what is the get board page function doing? It's not well, it's doing quite a bit really. So it's going to get the file where the posts are being saved. So I'm saving them in a CSV file, which if it's good enough for the British government, then it's good enough for me, right? Well, we'll learn in a minute that it's not. So the problem here with the CSV document is that it doesn't handle new lines particularly well because I have to format them, and I also have to have a comment delimiter which kind of separates those cells. So I'm just kind of using the what's this symbol? Section, string section, something like that. Section string, section separation. Anyway, so I'm just using that to split it up. So if you write a message using this, it will kind of fall apart. So using a database would probably be the more ideal solution to use instead of CSV. So I'm getting that, and I'm just going through and I'm just kind of passing that CSV document. I'm getting out the particulars that I need. So it's the image path where it's being uploaded, and also the timestamp and the message box. Pretty simple stuff, and that returns as a HTML string, and that just gives us a port index. So the real kind of magic and kind of real what web servers really do is it kind of like takes post messages or get and post, so it's kind of requests and the other one which I can't remember. So in the HTML code, I've got a form at the very top which is for creating messages, and so here it gets quite complicated. So it turns out that when you want to send a form with an image in it or any other sort of type of data, you need to use like a multi-part form. Rocket RS doesn't support multi-part form out of the box. There's a conversation on a issue board, the official issue board on Git for it, and they've tried to be supporting it for years, but it seems to be that the best way to get multi-part form data to work is to use someone else's branch or someone else's crate to do so. So what a multi-part form basically does, it packages up the image and the text together, and then we can get a hook onto all of those. So here we are, we're just kind of getting out those options from the form data. Now it should be said that this macro here, what it's doing is whenever data is sent via post and the server kind of picks it up as an incoming request to the root of the server, that could be changed to something else. So for example, it could be changed to /app. And then when you do /app, then when you send that data across, then that will be processed. We're kind of taking that data. I'm not really sure how that kind of hooks up. I'm quite ignorant to that. But what I do know is that it does work. So whilst the multi-part data comes in, what we just want to do is we want to pass through that. Apparently that's the thing that it does. And then we can get to what we really want, which is the image and the message. Now these two things are values that are put in the HTML form, so it kind of knows what it's looking to get. If I had a different image in there, I could call it image 2, for instance, and it would get that out as well. So now I've got those two things. I just want to make sure that the image that I'm saving is kind of like a timestamp, because somebody might upload a similar or exactly same named image, and if that's the case, then I'll overwrite that image. So here I've got a pretty cheap system and just kind of taking the time right now in microseconds, and yeah, it should say micros, not millis. That's a mistake. And then just kind of copy. Well, first of all, it's creating that path, and then it's copying it over. So, so there is a potential problem with this. If somebody uploaded an image at the exact same time as somebody else, and it was called the exact same thing, but the content was different, one of them is going to be overwrit. So this is not the way to handle it. Probably the best way to handle it is to use some sort of UID, unique identifier, which you can calculate. I'm not doing that. So this is really interesting, and I didn't really know that this would happen. So when you upload a file through the form using a multipart, it copies that file locally on the server, and then at the end of this function, it will disappear. So you need to copy that file from the temp folder into the path that you wanted to copy to. Now, I don't know if that's the way that all servers work, or if it's just the way that Rocket is set up, but I thought that it would come in as a stream of data, and then you would have to handle that stream yourself. The fact that it's copied to a temporary location is like really handy, because you can send anything, and then you've got your file, you can just copy it. Like, that's it. I don't have to do anything else. I do kind of question, though. Well, I suppose it's got to live somewhere. So I don't know if this is the best approach, but it was certainly pretty handy, because now you're relying on read-write speeds of the hard drive to copy files across now. Right, and so once we kind of got that, we're just kind of going with the text. We only want to post text. Sorry, we only want to post text a file path if a file has been sent. So that's kind of what this is these options are kind of doing, really, nothing special. Getting the text out is a lot more simple. And then all we do is we write it to our CSV document, or we append it to our CSV document. And then we just get board of the page again. So after you've press the submit button, then the page will reload with the get board page function, which is the page where the board is generated. So really, that's it. Well, it's like 100 lines of code almost. Well, just a bit more, I suppose. Yeah, and yeah, so with a bit more 100-line or so code, we've got like a working image board, basically. So, right, okay. Is there anything else that I could? Yes. So I'm copying the files over here to the image board, and this kind of lives on the server. So all your files are kind of local. So I'm just going to quickly go some like important things that I learned using Rocket. Use the Rocket TOML for your public address. Sorry, let me, it's just easier if I show you. So, oh, it's not here. Okay, that's good. I've come prepared. I have not come prepared. Okay. Right, okay, I'm gonna have to cancel this a minute and just quickly show you what is in the TOML file for Rocket. So this is it. It's 2 lines for the Rocket TOML. Now there is, the whole idea of this Rocket TOML file is for you to publish sites depending on what type of publishing you want to do. So there's 3 types. I can't remember off the top of my head. There's like development, debug, and publish. So debug doesn't do, the server is kind of running debug potentially on it. I'm not totally sure. The other one, development, I think only runs locally, and the publish one runs on an IP. Now, I've only set up global because I'm not particularly interested in any of that. I just wanted something that would work quickly and out the box. So you can see here the address that I've assigned to it is my local address on the network, and the router forwarding is handling everything else. So that IP address is my my outward IP address, I suppose you would call, and then the router is kind of pointing that port number to my Raspberry Pi. It's an important thing if you want to get working. So the whole thing is built on these mounting connections of post and get requests. So yeah, another thing is that Rocket is more of a framework than for more sophisticated code that can do more things. So for example, the static files that I was using, static files don't work out the box of Rocket. You got to use another crate in order to get those static files working. And those static files are the images and the CSS and scripts and things like that you want to use. So behind the scenes, they'll kind of link up those things between the HTML and your local files. And the Rocket examples and documentation is excellent, so it's a great place to start. And use databases, not CSV documents or Excel or anything like that that could handle really important information where people's lives are at stake. Sorry if I feel a little bit bitter about that. Right, okay, well, that's the end of my talk. Is there any questions? You want to go over anything in the code or anything like that?
Hi, Chris. Thanks for going through all that. One area you went over fairly quickly was the actual how you work out the layout for your website. Was that just raw HTML, or does Rocket RS provide any support to help you with layout?
No, it doesn't at all. So it expects you to have static HTML files or for you to return HTML type strings. So it doesn't do anything else with HTML. It's as simple as it gets. So if I just show you the page source, this is kind of what's going on really. I've just created these div tags where these messages are going in, and then the style sheet as well is it's pretty simple as I've got the source for that, haven't I? Yeah.
So basically, this is HTTP server, right? Without
Yes.
any add-ons to help HTML development.
Yeah, it's mostly for making web apps, I think. So if you're kind of doing like a game, a web browser game, then you'll be using this potentially.
Mm-hmm.
For instance.
So the other option of implementing that kind of thing would be to have a HTTP server serving resources and the static HTML, and then for instance, JavaScript rendering all the stuff, right? And
Yes.
just asking resources for some structured data, not HTML data.
Yes, yeah, that's another total way to do it. So I don't really like running scripts on pages. When it comes to HTML, I'm really I prefer static rather than scripts and things. So this is why I've kind of chosen to do this way. But you are absolutely right. The use scripts is probably actually more of a.
I mean, so when it scales, right, it's getting more tricky because then probably you would like to paginate your posts, not send everything at once, right?
Yes, yes.
And probably that kind of separation would be just easier because you would have those post resources with something like a size, then page, and you would be asking the server for that particular page, right?
Yeah.
Do you know also how Rocket is handling concurrency? Is it all run on one thread, or is it multi-thread?
It's all multi-threaded. So if one request crashes, then the whole thing kind of keeps up because it is threaded.
So it's threaded with separation. So different processes, that means, or?
Well, I'm not entirely sure. That's a good question. It is threaded. The way that it kind of works with those macros suggests that it's with separation. The question that I've got for this though is, if multiple people are accessing that or updating the CSV file at any one time, what happens? Does the machine, does the process wait for access to the file, or does the file get rewritten over with the other write request? So I'm not entirely sure what would happen in that scenario as well, but it looks like it's kind of working. It's just...
We can smash it. We can try smashing it, maybe. Yeah, because that was my question, right? Like, I'm not sure if there would be any synchronization happening on the file. However, that might be solved, I don't know, maybe by the file system, because that's appending, right?
Yes.
But
yeah,
I don't know. In fact.
But you should be using a database rather than a CSV file. So that database should handle that type of request.
You want me to post one of the section markers to try and break it, Chris?
Where did you do that? Sorry, you did, or you have?
No, do you want me to, or do you want me to leave it?
Oh yeah, of course, yeah. Try to break it.
Is there a reason why you didn't just go down the route of, escaping or putting things in quotes and all that?
Well, because somebody might write a quote. I mean, like, the UC section signal mark or whatever it's called is something that people don't really write very often. The other thing is that this is for kind of like a demonstration, like a technical demo, to see what's required to set up this type of web page or create this type of web app. So I'm not particularly interested in the usability of it.
Mm-hmm. So you could probably use some CSV library, right? Because they usually do some sanitization of data and then they're doing escaping. But yeah, obviously,
the thing is that I totally agree. Yeah, I totally agree. The CSV library would be easy to use, but I just needed something quick.
Yeah, sure.
Yeah.
Is there any reason when you were getting data from that multi-part data, you were getting images, but you were removing text from collection?
Is this in the source file? Sorry?
So online, 31 and 32, right?
Yeah.
So from files you are getting images.
Yeah,
removing.
Yeah, so I'm not entirely sure about this as well, but I believe it's something to do with ownership and also the fact that everything is kind of temporary on the multi-part. So in order to, access and kind of manipulate the text from the form data, maybe I need to remove it from it. I haven't done a deep dive into the multi-part library, but this, the whole entire way that this is kind of set up just really shows my ignorance when it kind of comes to kind of server side like programming and development.
Are you planning on progressing with that project somehow?
Yeah, so the main project that I want, this is like a demo project for that. I will be continuing with it. I only need a technical demo. I don't need something which is going to be released and for people to use, because if that's the case, then I really need to spend some time. Is there any other questions? No? Cool. All right, well, thanks very
just
much.
One thing, probably on that Rocket TOML file, the configuration file, probably like usually with those configurations, you could, instead of IP address, you could specify asterisk, which could mean that it's gonna be listening on all the interfaces instead of hard coding your IP address.
Oh, is that something you want to do?
Try it. No, just a hint, right? Obviously, from, I don't know, security perspective or whatever, sometimes you want to limit that to a particular interface, right?
Yeah. I don't know if that's even possible, to be honest, because all the documentation that I read for Rocket doesn't suggest anything doing anything like that. But again, your experience in networking might be better than mine.
I mean, so that's from experience, but from different frameworks, right? It might be working differently. Yeah.
Right. Okay.
But yeah, nice.
Cool. All right. Thank you very much.
By the way, the Raspberry Pi is kind of like a constrained environment. With the Rust compiler run there, did you compile everything on the Raspberry Pi, or did you compile it on another server and copy binaries?
No, everything is compiled on the Raspberry Pi. You just install Rust like you do with Rust up, and it handles everything else. You don't need to worry about anything.
Cool. But there is a potential of cross compilation, right? As well for a Raspberry Pi.
What are you talking about? Is
like running compiler on your computer, but cross compiling to Raspberry Pi target, which is ARM, right?
Yes. Well, I suppose if you wanted to do that, and if it's possible to do that, then so be it.
Mm-hmm. I mean, so the cycle would be quicker potentially, right?
Yeah, but it builds pretty quickly. Anyways, so if I do a cargo clean.
For now,
What about
you start extending it.
Right, so it pulls in 245 libraries. So the clean build is obviously going to be slower, but the incremental build is pretty quick.
Awesome.
Cool. All right, thank you guys.
Right. So should I say something then?
So.
We should. All right. Yeah. So that's my first time I'm a virgin being MC. So now we're gonna be going to Roy, right? I think.
Sure, great. So hi everyone, I'm Roy Barken. I'm from Israel. I'm a C++ developer. Currently work for a finance company called Istra. And I really love C++. And more than that, I love watching C++ videos on YouTube, like especially like ones of the masters and the old ones. And what I'll do today, I'll share a little bit about an upcoming talk that I'm scheduled to do in a week for the C++ group for Dublin. So if you like what you see, maybe you can join that meetup or just next week's lecture. Okay, so great, let's get started. I'm actually going to talk today about C++ concepts. I assume many of you or some of you know a little bit about concepts. I think the parallel in Rust is traits, and it's one of the largest features of C++ 20. It's a way to more easily write generic libraries, templated code with a little less ugly meta-programming and a little and somewhat better error codes when you have errors. And to give you a little sense of what it is and where it is, here's a little snippet from a video from early 2014. Here on the screen, you can see on the right Alexander Stepanov, who's the person who wrote the STL for C++ years ago. And this is a course that he did like 7 and 6 years ago at the company where he worked, A9. So here's a little bit about concepts in 2014.
We have a whole bunch of concepts that we've used in all of our code, and these are all defined to type name. Right? It's just documentation today. Maybe at some point there will be a way in the language to express this. But...
Okay, so as we can see, even in 2014, there was no concepts in the language, but still library writers went ahead and wrote many preprocessor defines. They had their names of concepts that they wanted to use. Totally ordered pointer, output iterator, input iterator, etc. They were all defined to the word type name in C++. So the language didn't know anything about concepts, but still the expert library writers already 6 years ago went ahead and wrote these defines in order to use concepts in their code. This leads us to know that concepts are swappable. There are dozens of these types of type traits and ways by which our library code can check various Boolean expressions on types that we use and on the relationships between them. This has been with us for a very long time. I think a lot of them have been with us since 1998. So it doesn't seem so new to us. Similarly, for overload resolution, we already had the template specialization for a long time and partial specialization, as well as STL was quite famous for using a method called the tag dispatch, by which every type of iterator and every type of container had a category. And the STL and Stepanov used this trick and mechanism in order to be able to choose at compile time which algorithm, which sorting algorithm, which searching algorithm, which transform is best used for different types of containers and iterators based on those categories. So all of this mechanism already exists. Now, the ways that the compiler chooses which of an overload set are to be used works a little differently for concepts than from tag dispatch. And in the talk next week, I can tell you a little bit about the pluses and minuses of each of the methods. It turns out that concepts, at least in my opinion, aren't just better than tag dispatch. They're better in some ways, but the old ways are also good and better than concepts in other ways. And next week I can dig deeper into that. So that's also something interesting to think about. When it comes to semantics versus syntactic requirements, things aren't as simple as they seem. And already, even in the C++ standard, in the language, we already can see some examples where things are a little bit cracking, a little bit not as easy as things might appear. So I'll give two examples from the actual C++ standard that has been vetted by many people. So first example is the size method for a standard list. So standard list is a linked list, and the size method has only been declared by the standard to be a constant time complexity, or O of 1 complexity, in the C++ 11 standard. And in fact, before the C++ 11 standard, the size method of a list can be linear time functionality. And on GCC, by the way, many times, even if you upgrade to C++ 11 and after that, you will get the linear time size for a standard list only in order to be binary compatible. And this is very much unlike the concept. There are concepts about containers that someone can use, and the concepts would require, or would generally assume that if there's a size method, then the size should be a constant time complexity. But even in the standard before C++ 11, that wasn't the case. And another quirk or unorthodox behavior can be seen the other way around with the standard pair. So standard pair, for example, of 2 ints, is something that is very commonly used. It's many times it's used within other, data types in order to keep key value pairs, etc. A standard pair, if you look at its memory layout and the way it seems, if the two members are trivial types or plain old data types, it should be trivial to copy them. It should be trivial to just do memcopy or memmove to copy them, and doing that can give a lot of performance benefits. However, the type trait called is trivially copyable results in false for pairs, simply because of the way that the type trait is defined and the way that pair is defined. This also is something that can generally be fixed, and one can write a pair that is trivially copyable, but the standard is not. And they already knew about it before C++ 17, but they knew that if they were to make a standard pair trivially copyable, they would need to break binary compatibility with older versions, so they decided not to. So again, this is a case where an object actually meets the concept. It is a trivially copyable object, but just because of the way that the concept is defined, technically the compiler cannot return true on that Boolean expression. And that's something that's obviously can cause and hurt us in terms of performance. In the talk next week, I can talk a little bit more about it and about why that is and ways to fix it. So that's basically it. I'll go and give you 2 more examples of like very weird cases, and also as an opportunity to also point you to another very good YouTube talk about from Herb Sutter. He was the chairman, I believe, of the C++ committee for a long time, and he spoke just last month at CPPCon about ways to make C++ simpler. I'm sure that one of the strong points of Rust over C++ is that it's much easier to shoot yourself in the leg in C++. It's much easier to do complicated things and overly complicated things in C++. So here's a talk where Herb discusses ways to simplify C++ and a little bit about how it relates to concepts and to weird cases.
But now let's look at templates. Let's go back to a simpler version of the example with just one in parameter, but of a templated type. Turns out you have to write this nest of things. Basically, you're saying, if I should pass by value, so I should pass by value if it's trivially copyable and the size is less than some. Let's just say you can make your own predicate.
Okay, so this is, I won't go deep into what Herb is telling us about. It just is trying to give an example of how C++ is very complicated today. But what's interesting from our point of view is this is a concept type of code. You can see that Herb is trying to show us how to write different functions with different requirements. He uses the requires clause to differentiate between types that are should be passed by value or should not be passed by value. And he does it by using a concept expert bool template variable. You see, concept expert bool should pass by value v. And one could ask themselves, why doesn't Herb use a concept? Why is this should be passed by value v? Why is it declared as a context per Boolean variable and not as a concept? C++20 already, we have the requires clause, and he chose not to use a concept. So again, next week I'll try to talk a little bit when I think, or maybe why I think Herb chose to do that, and when are good places to use concept, and when it's better to just rely on the mechanisms that we already had before C++20. Okay, and the last example that I have, and almost my one to last slide, is another special concept called the equivalence relation. Equivalence relation is also part of the C++ standard. And look at that. This one is a concept that's defined as completely identical to another concept called STD relation. And in the note, we can see that the STD relation and STD equivalence relation are actually only or purely semantically different. There are no syntactic differences between them. The compiler cannot differentiate the way to choose between two implementations of two functions. One that accepts an equivalence relation, another that accepts just a regular relation, is not something that a compiler can do. And yet this is part of the C++ standard. There are semantic requirements, although the language doesn't do anything with them in C++20. That's another interesting thing to think about. And to some extent, you know, in 2013 and 2014, Strastrup was thinking about C++20 and concepts. Perhaps today they're already thinking about the next versions to come and trying to lay down the groundwork for that. So that's what a few examples and a few tidbits from next week's talk. So what you could expect if you join next week, you'll hear many of my opinions, a little bit of facts. You'll know what the things that were easy in the past and now aren't so easy. What were clear choices in the past, and now when we have more choices, we might get a little bit confused. I'll try to give a few tips and suggestions, and a little bit about where I would like to see the language moving forward. So that's about a little bit about that, a little bit about concepts. I hope you found it interesting. I'm happy to receive your feedback and questions. Thanks.
Would you want to post that link in the chat, just so people can click on it if they do want to sign up?
Yeah, sure. And I'll also post it in the Meetup comments. But sure, let me. Yeah, I'll do it. So where's the Zoom thing?
It's an interesting teaser. Thank you for that. Is it like I think I saw somewhere for a post from Eric Niebler, so the guy who created Ranges v3 library. So and as C++20 was almost concretized, right? So I think he was changing his enable ifs to concepts, and he said that he got like very significant improvements in compilation time.
Yes.
Right? Because there doesn't have to be an instantiation of a template happening just for a compiler to figure out that, oh, something doesn't match, but it's just known from before instantiation that it could be tried or not, right?
Yes, that's true. Concepts are really a major improvement to the language. Many things that used to be more complicated, longer compilation times, just harder to read and harder to reason about, became much simpler. And yet there are a few cases where I think it can be a little complex. But those are edge cases, but still can be interesting ones. And, in fact, a lot of next week's talks will be about the edge cases. I think you can look a little bit at some of the lectures that I posted in this presentation, and I can also recommend a few more. As you mentioned, Eric Niebler is a great source for the common way to do it and what are the best ways for using the concepts.
Mm-hmm. Also, I think it was Bjarne saying that you shouldn't be creating your own concepts. You should be using just the concepts in the standard library, because like creating a concept is setting that in stone and it can never be changed, I think, right? Is there a requirement like that?
Yeah, so definitely I guess, yeah, the decision to create a concept and how to do it seems very, very non-trivial. And but still, it's part of the language. So one might think, okay, so what should I do with it? Do I only sit back and use the existing ones? Do I add my own? And I will try to discuss a little bit of that next week, and especially give some either escape hatches or ways in which one could maybe design their concepts such that it's a little bit more future-proof or a little bit more or easier for library users to interact with it. Okay.
Yeah, with the simplification of C++, I think recently, I think it was a lightning talk by Bean Den. So he was using const expression lambdas, I think, to simplify like a few helper templates to define one template and just pushing all of that into one template declaration. I think it is, right? Before, yeah, of definition. In fact, yeah.
No, it's really tricky stuff because you know, the new features make new things much easier to write if you know what you're doing, if you know about them. But still, if you don't know what to look for, you have many times like tons of alternatives to do the same thing, and it's not quite clear what to choose from. And if you're just reading someone else's code, you find yourself needing to understand what's their level and what they probably know and not. So it is, I guess, a different level still than Rust, unfortunately.
All right.
Yeah.
Yeah. Thank you very much. Oh, by the way, did you attend any CPP core CPP? I think, right, in Israel.
Yeah. So yeah, I do. I actually gave a lecture on core CPP about 6 months ago. The company that I work for, called the Istra Research, we sometimes sponsor their event. So and they're good guys, definitely.
Awesome. Right.
And I think, by the way, that they have their meetup later this week, maybe tomorrow or the day after tomorrow, if you'd like to join. It's also virtual. Yeah.
Thank you very much. Anyone maybe else has questions?
Hi, Roy. Thanks for that talk. It raises an awful lot of questions, but I got a feeling a lot of them I should wait until next week to see your longer talk to see how many of them get answered then. I guess the main thing I kept coming back to, are constraints only, concepts only useful for trying to manage compile time checks? I'm particularly interested in things like being able to control and make things type safe with things like non-empty vectors or non-zero values, but those, as far as I can see, could only be checked at runtime. The closest I can get to is creating a new type that gets checked on construction, but then you could rely on the type from then on. But can you see any way that concepts could help me?
I think basically you're right. Most of the work around concepts and most of the functionality that you get is in compile time, not in runtime. There are a few things that some people can do to help. First of all, maybe it will be seen later, even today. Some people can use like variant types as a way to, for example, discriminate in runtime between like an empty vector or a non-empty vector, or like a non-type or a vector, and then concepts can then be used within like a runtime visit function or visitation function, very much like the pattern matching that's done in Rust. So that's perhaps one thing that can ease your way. But as you mentioned, a lot of it is compiled. There's also something called the CPP core guidelines, and they have a support library where there's like a special type called the not null. And not null is sort of like a smart pointer that isn't smart at all, but you use it to specify that you want this pointer to never be null. And there are ways for like static code analyzers to look at uses of not null, and they give you again, like warnings, like linters, etc., telling you, hey, you're passing a not null value over here, and potentially assigning a null into it, etc. So maybe that can bridge a little bit of the gap.
Okay, thanks.
Sure.
By the way, guess who's giving a talk on variants?
It's probably not helped because I think my my Zoom name is coming up with my daughter's name. Right.
All right.
Okay.
Oh, that's true.
Cool.
So are we having a break to grab a coffee, tea, or have a leak?
Yeah, I think
Or
5-minute break, maybe.
Yeah, here
How
in
long
Israel,
did you
it's
say?
coming up to almost like 9:35 p.m. So time for a beer, I guess.
So 5 minutes break then? Did you say 5 minutes?
Yep.
Yeah, I need a glass of water.
All right. See you in a bit then. Thanks.
Thanks. So how come you got the short straw today, Krzysztof?
Oh, you mean MCing or?
Yeah.
No, so I was meant to give a talk, right?
Oh, of course.
Yeah, I didn't manage. I mean, so it's not like, so I was procrastinating writing the presentation itself, but like collecting material, I was doing it, right? So
Yep.
I can only half blame myself, right?
It always takes longer than you expect.
No, and also, so with these, so that was modules, right? And with modules is that, so right now there is implementation of the compiler that supports modules as they are in the standards, right? Which is Visual Studio on the preview. And Clang only supports with GCC, I think they only support modules CS, and there are differences. And you know, so I started reading papers, right?
Yep.
And oh, there are so many papers, and you know, you just start reading them, and obviously they, like, if you don't read it in the proper order, then it just messes in your mind.
Yeah, modules is a big subject.
Oh yeah, but in the end, I'm not sure anymore if it's that useful, right? So I was like, yeah, I could finish that talk, or I mean, so I would have to take like a whole day off, I guess, to finish it today. But then I'm not still sure what the strength of the modules are. I mean, so I know what
that scarily seems to be the conclusion that quite a lot of analysts have come to listening to podcasts and things.
Yeah. So the problem is again breaking existing code, right?
Yeah.
Yeah, like the original module TS, or like the original idea was to get rid of leaking off macros and everything, because the macros are the source of evil, but not necessarily, right? You need macros, and you've given a talk. So we all know, and yeah, like some macros are part of the API of the library, and then this is when they're useful, right? And some macros are not the API of the library, and they're still leaking, and the point is to basically to reduce those. But then yeah, there are problems like you break the compatibility with the existing code, and that means no one would be using it.
Yep.
And yeah, so there is a history behind all of this, right? And then they came to some solution, and yeah, I don't have so strong feelings about that. So that was something that I was trying to grab before giving that talk, and then I just didn't manage to finish all of this.
Yep.
Yeah.
That's
So
right. Got to save something for the next meetup.
Mm-hmm. I was defeated by modules this time.
Yep.
By the way, one thing that I heard about modules quite recently, I'm not sure if it's completely true, is that they are much more strict than currently than includes regarding cyclical dependencies. Right now with include files, you can just do those include guards and have one header file include another and have a cycle. And if things happen to compile, then it just works. When the modules won't let you do anything fishy.
Yeah, so in normal includes, you have pounding the header guards, and then you just oh, forgot the name. You have pre-declaration, forward declaration, right? Whereas with modules, you cannot have the forward declaration in module because module owns the symbol. So if one module that depends on the other module that has a declaration that owns the symbol, and if you want to do the forward declaration in that other module, then basically you have two modules owning the same symbol, and that's forbidden, right? So you have to break the modules, you have to break the cycles. But in fact, it's a good habit when developing big code bases, right? So like, hey, can you just go, please? Yeah. So it
hates cyclical dependencies.
It might not be good for from the perspective maybe of a person who wants to quickly write the code, but if you want to appropriately structure your architecture of the code, then anyway cycles are bad, right? So like yeah, lots of the people are saying this is not a limitation, in fact, right? There are other limitations.
Okay.
Yeah, so compilation speedups, for instance, are one, right? And
yeah,
again,
that's
like
what we're hoping. Compilation speed is a very big problem for us in work, and the biggest gain we got was a huge refactoring to try and get as much implementation out of headers as possible. And a big part of that was relying on forward declarations whenever anything is being passed by reference. And that made a huge difference. Certainly on our Unix builds, it was a factor of 2 or 3 times faster to get everything out of the headers and to not include the actual definitions unless you really needed to. So pretty much only if you had inheritance, everything else you could just get away with forward declarations. It made a huge.
Yeah.
So now if we go to modules, and then you do have to link against a module in all cases that you're going to use that symbol, hopefully the gains from having pre-compiled each module, having built the intermediate file, will offset the gains or any losses from moving away from forward declarations.
Mm-hmm.
Yeah.
But we'll see.
Yeah, so there are also problems with, like, there is only, I think, one build system that supports modules at the moment, right? Which is build 2, and none of the other CMake, make files, nothing really supports modules, because there is extra dependency that needs to be calculated during scanning of the code base, basically, right? And that's something that is obviously it's a next step. That means also analyzing some of the files, and that adds that adds extra time to the compilation of the code base. Incremental compilation is going to be faster because those dependencies are already scanned. Yeah, and it cannot be resolved like with the headers. So if you have a build system, and obviously you build your code and then you modify a header, you expect all the dependencies of that header to be recompiled, right? But that can be omitted during the compilation of all the translation units. So and that's what the build systems are doing, right? Whereas with modules, you'd have to do that scan first to figure out what depends on what, then schedule what needs to be compiled first, because the other module that depends on some other interface of the other module, then the interface have to be built first, right? So yeah, there is that additional thing. And so from what I've read, what I heard is that all those improvements depend on how the code base is written, basically. There is nice talk, but from the guy from Google, and they started doing that modification, so migration to modules, Clang modules, before, I think it was even before modules TS was established. So that was Clang modules, and they were sure it's gonna be speeding up everything, and like compilation sped up, but so it seems to be better. But then all the CPUs were working harder. so obviously they're using a big infrastructure, and they were telling their infrastructure guys, all this migration is gonna make it cheaper, and everyone's gonna be more happy. And obviously they weren't. And then they still had to do, like, analyze what is introducing the problems, change the code base, and so on. So probably migration is not gonna be that easy. But obviously the new code could be written with modules, so maybe in 10 years time.
That makes a good teaser for your talk for next time.
Yeah, or maybe I've already said everything I know. I have some images and some code examples, so yeah, that's gonna be at least visual. And then I'll tell all of you that, yeah, I'm not sure. Cool. So shall we continue then?
Oh, I guess, yes. Should
Right.
do it if I can remember how to do this.
It's been a while.
Okay, can you see my browser page?
Yep.
Okay, let's get this. Okay, for those of you who haven't met me before, I'm Richard Shepherd. I work at Esri in Cardiff with Ciara and Chris. I've talked before a few times on different things, most all C++. This is my first time trying to talk about any Rust. I'm certainly very keen on the Rust language. It was very interesting to hear a long-term C++ expert on CPP cast recently talking about C++ and Rust and when you would use them. And basically, he ended up concluding that if you were writing pretty much any sizable project from scratch that didn't have to interoperate with existing libraries or your legacy sort of environment, you would start with Rust, not C++. He could see very little reason why you would start a fresh project with C++ now. You may have been exaggerating slightly, but I can see that Rust has got an awful lot of good ideas in it. And certainly reading Rust helped me understand move in C++ a lot better, which wasn't the way I expected. Anyway, getting back to tonight, I was going to talk about variant that I've been using in Anger a bit in the last year or so in work. And I had a few challenges trying to get variants to behave the way I wanted. And so I'd already done a comparison for a work article about different ways to work with variants. And I thought it'd be nice to extend that and see, well, how would it compare to trying to do the same thing in Rust? So the way I see variants, this is the most texty slide, so they get more straightforward after this. The way I see variants is as a different sort of polymorphism, or a different way of handling polymorphism. So we're very used to, certainly in C++, building a lot of the components and systems I've worked on of using inheritance to design by interface. So I keep different components decoupled. They know about base classes of each other, but that's all. And then either side is responsible for implementing classes that satisfy that implementation. And that works fine when you want things completely decoupled, and importantly, when you don't know what new types are going to be added that want to satisfy this. Templates give you static polymorphism, so at compile time, if you know exactly what types you're going to be working with, you can get the generic coding aspects. It gives you a different sort of safety because it's not relying on semantics. Templates require or rely more on duck typing. Pretty much any type that you try and apply a template to, if it supplies operations that fit with the code, then it allows them to build. So it's a lot easier to extend them than a hierarchy where you might need access to some of the original code to be able to insert things into the hierarchy. Templates, you can just create sort of new traits or new specializations of your templates, but it's still all at compile time. And if anything, it's all a bit unconstrained. Variants seem to give a nice compromise. If you know how many types you've got, it's not going to be changing. You want your program to model all the types. Users aren't going to be extending it for their own purposes. Then traditional OO dynamic polymorphism seems a little bit too open, and you could really more efficiently constrain it to a certain range of types. And it also changes the sort of code you can write. Whereas with traditional code, you'd have to gather all of your functionality together in a class. So every time you add a new instance or type to that hierarchy, you create that class and you implement each of the methods that's required. In some cases, this makes sense. But for some other functionality, particularly if you know all the types and you're writing quite complicated code, you'd rather cross-cut it the other way. You'd rather have one function that deals with one particular aspect of your functionality, and within there, gather together all the differences across the different types that you know about, and it makes it easier to maintain. Like everything, they're design decisions, and there's no one answer. But certainly I see variant as a powerful additional tool, giving you some other options if either inheritance or templates don't quite fit the bill. The particular case I was looking at, I was working with sets of geometries or with geometries that be passed to me, and in particular working out what sort of changes were being made to these geometries. And if they were very simple changes, then I could do a lot of optimizations and simplifications. If they were complicated transformations of the geometries, then I'd have to go down much more complicated paths. The bit we're interested in here was just modeling what kind of transformation. So I only had a very limited range of transformations. Nothing was going to be added by anyone external. If it was ever extended, it would be sort of internally within our team. So I only had 4 or 5 very simple transformations to manage, and then some simple bits of analysis to be done on each of them. It seemed to be a good case for using variant. to try it out. And that led me on then to wondering about how to work with the variant, basically how to, within my code, how to actually manage the switch statement between the different types. And because variant is provided as a template library, and all the functions for working with them are library functions, so none of it is part of the language. It means, or it does mean, that there are a number of typical ways of trying to work with variants, to choose between the various types within a variant. So initially I wanted to experiment, or I wanted to work out which is the clearest in terms of describing my intent, which is the easiest to get right, and to actually be able to work with. And lastly, the efficiency, which is with performance problems with trying to work with them. How did they compare against sort of the old days when you just have had a C union and your own enum and a switch statement, which is pretty much what a union a variant ends up being under the hood. It's a union of the types with a hidden enum that chooses between them. But I wanted something that's safer and more correct, but hopefully as fast. Efficiency I put at the bottom of the list there, because even though obviously we want to use the mechanism that's as fast as possible, really that's not where the bottlenecks are in the software that I'm working on. And although the performance profile I did uses sort of billions of calculations to try and get a meaningful time, it's not actually very representative of the real world uses. The clarity and the correctness, I think, is more important. Okay, to give you an idea, okay, to show you some code, much more interesting. So the class, so I implemented it first in C++. So the transforms I had, the easiest way to set it up was to create separate structs, one for each of my types of transform. So you can see they've got different elements, they've got different data members, they've got different sizes, and then I constructed a variant of the 4 of them. So it's fairly straightforward and clear and clean, no problems with that. And then I was looking at the different ways of trying to choose between them. So typically, what I would expect is I'm going to have a collection of these transforms, each of which will be one of the different types. And for each of them, I want to call my calculation function. So this is an entirely unrealistic function that I created to give me different behavior dependent on the type. So that I'd have something to easily calculate, and that I could then time and easily compare the different implementations. So in this case, for each of the different types, all I'm doing is using some of the data members to extract a value, which I'm going to do a simple calculation with. So don't expect them to have any actual useful meaning. So the simplest case for trying to decide which transform I've got, it's come in as a generic variant type. And I can use the library getif function on the type, and that internally that'll be looking up the enum value that's hidden inside the transform variable and seeing whether this type corresponds to the variant type that's coming in. So I end up with a set of if statements, one after another, and if it is able to successfully, if it recognizes it is the right type, then it'll return me a pointer to the object of that type, so I can then dereference it and pull out the members I want. So you can see here, because the C++ if statement allows me to declare the variable inside the if statement, it's scoped, so it only lasts as long as that if statement. So even though I've used the same variable name, they can have different types and different meanings in each instance, because they're only scoped to within the single if statement. But then I can pull out the different members of it depending on which type it's being cast to. So it's doing two things: it's checking the type and it's giving me access to its internals. So it's, it's reasonably clean and clear, not too bad. An alternative, which I quite liked the idea of, was using a switch statement. So rather than having to wade through a whole chain of ifs, that would be as many ifs as there are in types in your variant, which might then give you performance considerations. You want to try and order them so the most likely ones come earlier in the list of ifs. A switch statement should allow you to jump more efficiently, and you can, with a bit of fiddling, get at the index. You can get the index for the variant, so that basically is giving you the internal enum value, which in our case should correspond 0, 1, 2, 3 to the different types in our variant. What you can't do is actually find out what the number is that corresponds to each of your types. There's no standardized way of doing it. With a bit of template programming, you can write a recursive const expert routine that will do it for you, basically by trying all the numbers until you found one that matches. So with use of that function, so this, although it looks like a function, it's actually all carried out at compile time to work out what the values are. So this all turns into the number 0 in this case, and similarly the other one turns into the number 1. So I end up finding out what the enum values are that I can then switch on my runtime index value, enum value for the transform, and it'll jump to the correct place. What the switch statement doesn't do is any sort of transform for me, so I then need to do, I still need to do the cast to actually extract the value from the transform using the get before I can dereference it and get at the members I want. But other than that, it's exactly the same form as with the ifs, but it's now a switch statement, so it should be able to jump slightly more efficiently to the values it wanted. The next mechanism I tried was exactly the same, apart from using getif. I was curious to see if getif was any slower or not, whether it took extra time to make its decisions compared to just doing the cast. But other than that, it's identical to the method above. And then the more interesting ones were the official ways, if you like, to jump between different variant types. So this is using the standard visit method that Roy mentioned earlier. I'm only using it in the sort of most straightforward way you can. So the standard visit method, you pass it a lambda that will take your variable, and then within it you can use const expression comparisons on the type, which if you forget its const expression and just imagine it encountering, this is a function at runtime that was going through your type and checking it, and you could do, if you could imagine you could do runtime comparisons, then this logic all makes sense. It's checking the type, and then it's able to get at the value in it. Note, I'm not actually having to do any sort of a cast on it now. It's automatically figuring it out. Obviously, it's not doing these type checks at runtime. It wouldn't make any sense for it to do so, so it has to do them at compile time. My rough mental model of how this works is that standard visit over your template, which it knows about because you're passing the variant parameter in, at compile time, it iterates through all the types in your variant list and runs this lambda for each of them, if you like, or creates a version of this lambda for each of the types in your variant, for which only one of these const expressions will actually be valid and all the others disappear. So it's certainly a more heavyweight use of template machinery to make all this work, but once you've got the format, it's very similar to any of the other switch statements in terms of what it's comparing. It's not, I admit, it's not very obvious syntax. Lastly, if you use a little helper function, you can tidy it up a little, where you actually, in this case, we've created a structure which we then instantiate with a list of elements, each of which is a lambda for all the different types, and it gives you a slightly cleaner version of it. So again, it looks roughly, if you squint a bit, like a switch statement, and getting access to all the individual members of the elements. So they're all different ways of trying to take apart your variant and trying to get at the different elements. And the last two particularly involve an awful lot of template machinery, So I wasn't at all convinced how well they would perform compared to a much simpler if statements and switch statements that C and C++ have been optimized with for many years. So I built a simple little test harness. All this does is create a large vector of objects, each of which is going to be either or one of these four types. I deliberately mixed it up a little bit so they wouldn't just be sort of continuously alternating, so it regularly misses some out, so they don't have a completely regular sequence. Hopefully I can defeat any of its caching of answers, and it doesn't start to recognize the if sequence too easily. I created them, filled them full of random data, and then that only gets done once, so it doesn't really matter how efficient that part is. The actual work being done that's going to run over it, in C++, I wanted to run the same calculation for each of my different switch mechanisms. So I templatized the timing calculation on the switch function that will get passed in. And then, so within it, I'm basically just going to loop through all my data multiple times, apply in my switch function to get a number back, and just compute a total just to get something out of it so it doesn't optimize it all away, and time it all. So finally, the main itself, all it has to do is, for each of the mechanisms, run through the data, get in the timing. And assuming I haven't managed to break anything, actually run it, so that the numbers that come out of it have no useful meaning. They're just there as much as anything to prove to myself that I haven't messed anything up, and that all my different methods are actually computing the same value, running through the data, and how long they're taking. So the straightforward if statements, I realized I had to be a bit careful with my first few passes at this. I didn't set up the data to be entirely evenly distributed, which meant that the if statements would give me wildly varying results depending on how heavily weighted the variations at the front of the list were compared to the variations at the back. So once it was evenly weighted, then I got much more sensible and consistent values out of it. Just letting it run. You can see at least I'm getting the same answer on each one, which is good. I have run this numerous times and get roughly the same numbers each time. It's not a perfect mechanism for doing performance testing. There are some good online websites you can use that will give you more accurate performance benchmarks, but this seems to give me enough for the purposes of this talk for comparing things. And main conclusions from this is actually the heavily templated methods using the visit functionality are actually pretty good compared to much older switch statements and if statements that potentially had decades of work on their compiler performance. The only one that's really out of sync is where I used both a switch statement and the get if. So effectively I'm doing the decision twice, and that appears to make the difference and sort of waste a load of time. So pretty much go with one or the other. Trust your switch statement or use the get if, and you get comparable results. So if I jump back to my slides, remember where I was at. So that's what I did with the C++. Conclusions on it. I actually found it quite difficult to create the structs, although I ended up with quite a clean result. What I wanted when I started, oops, I haven't got numlock on. What I wanted when I started was to create a single type called transform, and ideally I would have then had all the others inside it, so that they were namespaced within it. And I could do that, but then the variant itself has to be within the transform, and so that ends up being a bit awkward. So I couldn't quite get it combined the way I wanted. I had to have them as separate structs, and then the transform type as a composite of them. So I was a little frustrated by that. Because everything is library based, the syntaxes can be quite verbose and fiddly to get right. But once you've got it, it turns into boilerplate. You could even use a macro if you wanted, if you were using it enough everywhere and didn't want to keep writing all of it. Although it wasn't too bad. As I mentioned, on performance-wise, combining switch and getif was a bit of a wasted effort. I was quite impressed to see that the visit techniques actually worked as well as they did. I thought with all the extra lambdas and layers that might not actually work that well, but it actually did pretty well. And both mechanisms were good at detecting if I accidentally missed cases out. So switch statements, certainly with some compilers, if you delete one, don't cover all the cases, I've got no default, then it'll complain if I don't cover all the cases. In fact, switch statements don't work in this because it's not clever enough about it. It's not a proper enum, so it can't figure out I haven't covered all the cases. So that is a weakness on the C++ side. But sorry,
Richard, but you could put default there and then static assert, right? Probably.
Yes, yeah, you could. That wouldn't catch it at compile time though. That would only catch it at runtime. Oh, I see. If it fell through, you mean? But could you? Because this doesn't have an enum type. It's only got an int type coming back from it. It can't check all the cases. If it was an enum class, then it could.
But it's a constexpr function, right? So you just hover over index, and that's constexpr. So most probably that could be inferred, all of that in compile time then.
I shall try that. I'll try that and see if it can.
Mm-hmm.
I won't do it right now because otherwise I tend to overrun. But it definitely does work if I try and take out one of the elements of the visit, although the error message it gives me is not terribly helpful. It doesn't tell me what's going wrong. I wanted to then try a Rust equivalent to see what it would look like and what its performance would be like. Being comparatively a much newer compiler, I wasn't sure how much they would have optimized such things. I'm also well aware that I've got far less experience in Rust than C++, so there's a good chance I'd make mistakes. So before I plowed into the Rust version, I thought I'd better just make sure I can get a simple comparison. Does Rust and C++ compile even for very simple examples to something that's comparable? So I created just a little calculation that I could run. In this case, it was a floating point calculation that I would run 3 billion times just to try it out in C++ and to do the same thing in Rust, just to get some confidence that I was comparing like with like. So if I just run that, press the wrong button. So it's a simple floating point calculation. It has to work through it all. Apparently I wanted to check that we're actually using the same floating point tools underneath the hood, the same intrinsics. So I got 11.8 seconds in C++. And if I built the same thing in Rust, so this is the first time you get to see some of my Rust code. It actually looks very much like the C++ code. And I know you can set up Studio Code to run it directly from there, but I found it easier just to get a command line up and running to build things. So if I could run that by comparison, I thought this would take, well, I didn't know what to expect. So I was very pleasantly surprised when it gets there. Okay, firstly, I was very pleased that I got exactly the same number. So it is using exactly the same floating point intrinsics or runtime library under the hood. There's no difference to the floating point calculations it was doing, which was important for the rest of my comparisons. And the time itself was extremely comparable. So they're both building for certainly straightforward calculations. They were resulting in very similar executables. I could have gone further and looked at them both in Godbolt and start comparing exactly what they built, but I'd approved enough for my purposes that I could feel that I could get a useful comparison out of it. So I moved on then in Visual Studio to building the same code I'd built in C++. So if you remember, my original structs and variant, and then compare it against what I built in Rust. Pretty much that page there turns into well, a rather smaller bit of Rust code. Basically, Rust has got this as a language feature rather than as a library add-on, and is almost designed perfectly for the situation I had. I could, in fact, it definitely wants me to create them as types that are scoped inside the overall enum. You can build up an enum using alternative external types, but then you have to wrap them inside it. So for some uses, it would actually be more awkward to use Rust if I wanted it to be composed directly of external types. But in this case, I was more than happy to use types that were purely existing within the transform. And it was certainly much more succinct to create the types. So I guess I could have got the same effect there just by squishing all these onto one line. So it doesn't make a huge amount of difference, but it made for quite a nice syntax for putting that together. And then the actual calculation, you can't get much more straightforward than the match statement that Rust gives you, comparing the type, accessing the elements of it. It did take me a little while to figure out. I did have to, because the components are structs rather than tuples, that I had to actually mention them by name, even if I wasn't interested in their value. Particularly as it then got upset if I didn't use them, so I had to mention them by name, referring to what was in the struct, but then tell it that I wasn't interested in them. So it took me a little while to make the compiler happy. But overall, the end result of it was very short and succinct code. I guess the closest comparison is probably the final set of visit code we had in C++, where you have to do it basically with a list of lambdas onto the types, which wasn't too bad, but you get quite a lot more type boilerplate that I wasn't interested in. So I was certainly pleased with the results. Setting up the test data was almost identical, and I got to build the same calculation and run the same times. And if I've still got them on screen, I guess the proof of the pudding that I've been waiting for is how does it compare time-wise. So the only things it complains about is that there are some elements of my variant structures that I never got around to using. But the actual values, firstly, I was pleased to see, I managed to get exactly the same calculation happening, and got to say, Rust beat the hell out of C++ on the actual overall calculation. I can only, it can't be doing that much differently, but the fact that it's there as a language feature rather than having to be a library feature presumably means that it can use internal, or it can use compiler optimizations, because it has a much clearer picture about exactly what it's doing. I can see I was only doing something very straightforward and simple, and there's lots of sort of cases I could spend more time on, try and add more cases to it, or making the calculations more difficult. And if I want to put a lot more effort into it, I could compare again the binaries in Godbolt and try and see roughly how much difference it's producing in terms of code. But I was pretty astounded that it could manage that much of a speed up, that it had knocked sort of 30 or 40% off even the fastest switch time. The one last thing I wanted to do on the C++ side that I ran out of time for was construct a version that does do it purely with an old-fashioned union and an enum and a switch statement, and see if that managed to go any faster than the other C++ methods. But the end result of all this was it wasn't too difficult to write Rust. In fact, pretty much when I got the last compiler bug out, and it finally actually compiled all the way through, it ran perfectly. I couldn't quite believe it. The code was actually correct. The number of, it's not exactly complicated code, but the number of constraints the compiler enforced on me in Rust, I did actually have it right the first time it actually ran all the way through. So there's no debugging required. partly which I put down to the simplicity of syntax and the careful type matching, making it very difficult to make silly mistakes. But overall, I was impressed and would have no qualms about using Rust in a performant scenario, and certainly the simplicity of the syntax lends itself extremely impressively to what I was having to struggle or come up with different competing, none of them completely satisfactory methods of doing it in C++. And was there much else in my slides? Rust conclusions. Oh, the other thing was, yeah, I certainly got more helpful error messages if I excluded things from the cases, if I accidentally missed one out. In fact, I guess you guys won't be surprised. If I try and exclude something, I don't even have to compile it before it's immediately giving me squigglies to tell me precisely what's going wrong, that I'd missed the extra vertex method that hadn't been covered. The C++ comparative messages are nowhere near as immediate or obvious. If I'm not sure if it copes with the extra trailing comma. If I try and comment that out and try and build, what does it tell me? I get the fact that the invoke has no matched overload function. Okay, does it even mention transform in there? Change. So it tells me the variant. It gives me a number of clues. I could find roughly where I am in the code. What it doesn't tell me is exactly which type it is I'm missing. So I certainly have to work harder in the C++ case than in the Rust case to actually figure out what it was I'd broken. So I definitely agree that Rust, I guess, I mean, that's not just down to Rust and its compiler, it's down to the fact it's a language feature rather than a library feature. But I was quite impressed with how easy it was to use. Places to go after that. Interestingly, I was quite interested to see that Roy was on talking about type traits and concepts, because I'm more and more interested in sort of constraint-based programming and what else we can do in the type system to enforce things being correct earlier on at compile time. And I've experimented a bit with Rust type traits, but not enough really to be able to talk about them. Maybe another time. As always, I've run over a bit longer than I expected. Any questions or thoughts, anyone?
I have one question. Did you mention that you could try a variant of Lambda functions and just invoke those directly?
The mechanism
on the C++ side, right?
Yep.
So obviously Lambda is just a callable object, right?
That's right. Yep.
So you could have each of those transformation lambdas.
Yep.
Decal type them just to have something nicely looking using, right?
Yep.
And then I wonder how speedy it would be if you just visited, not even visited, right? But if you just had a templated function that invoke on it, would it be possible?
It should be. I don't know if it'd be any faster. I mean, I guess direct function pointers might be. I don't know what a standard visit uses. I guess it's standard visit. Std visit is having to use std function inside it to actually hold the lambdas.
I don't think so. So I think it's the variant, it basically is like union, right? So it allocates as much plus aligned space as types need. And with lambdas, if you see the declaration of lambda, you can explicitly, or you can straight away allocate, or you know what the size of the object is, right?
Yep.
So it could be maybe faster. Obviously, then like the logic of it working would be different, right? Because you wouldn't be working on on data, you would be working on functions basically, right?
Yeah.
So yeah, I wonder
that'd be a possibility.
that's...
Yep. No, I shall have to try it out.
I found this talk really interesting. Thank you.
My pleasure. It's all up there on GitHub if anyone's interested. I don't know if I put my GitHub account on there. I didn't, but I can put it in the chat.
You post it on the meetup afterwards, like
Yep.
That's probably a good idea because then everyone has access to it after the meetup.
Good idea.
Anyway, the performance difference between the Rust and the C++ implementations is really remarkable.
Yeah, can you dive into that a bit more, Richard, and come back next time with the answers why that is?
Go on then. I'll put it into Godbolt and I'll see if I can figure out why it's different, and I'll also try some of the other C++ alternatives and maybe do a follow-up talk.
Because the input data you said was the same, right, on both?
Yep. I'm pretty confident that it's using exactly the same input data because we got exactly the same quite complicated answer. It'd be difficult to get that by accident. Certainly when I changed the value, like number of iterations, it did correctly change that value. So any slight deviations would have knocked that all over the place.
Any possibility there was like implicit type conversion going on maybe somewhere? Because like on Rust, you need to get those types sorted yourself, right? Whereas C++, it can coerce types. Maybe something like this happens. Possible?
It shouldn't have been in this case. I was fairly careful with the types that it was using. So everything is sort of strictly just using doubles and the unsigned ints for looping over it. So I did go out of my way to try and check that it was definitely using the same types in both. But it is possible. And the fact, I guess, I checked the underlying mechanics by doing the other performance-based line. But I guess I'll try and find a C++ version that is at least comparable, or at least a convincing explanation for why the assembly looks different.
Is it worth trying a different compiler as well for the C++?
It could be. I mean, the Intel compiler always used to traditionally produce pretty good code. Whether they've got a free version available for that and see what that'll do, or even GCC.
Which version of MSVC is that you tried?
Latest-ish, I believe.
Oh,
you did build with optimizations, right? You did.
I did, yeah. So both of them were on optimization. That was partly why I did the baseline of standard sort of simple calculations just to make sure. But yeah, it is on the full optimizations.
Everyone's just desperately looking for a way that C++ can be faster.
Yeah, so you did mention that std visit invariant is part of the library and not the actual language, and it might be of importance here. Definitely it could. I noticed in the past that the requirement for std visit is for it to be a constant time, so it has to be implemented with a jump table, and sometimes a jump table isn't the most efficient way to do these things. So potentially there's something there. I know that there are competing implementations of variants. There's one by a person called Michael Park. You can find it on mpark on GitHub. Where he has his own variant implementation, which is supposed to be faster.
Okay.
Yeah, I wouldn't want to drop all of this on you, but maybe I'll take a look at GitHub and see and look at it a little bit as well. Probably after next Monday, but
yeah.
Richard, you're not gonna have much sleep tonight.
More concern is my family are waiting for their dinner, so I'll have to head off in a minute.
All right. So shall we quickly move to Ciara then? Thank you once again.
Thanks.
Yeah. You definitely know all this, Richard, so I won't be offended if you bounce off. Try and this through. Okay, so just want to do a quick talk on tail recursion because I read some inflammatory statements saying that Rust didn't have it, and I got very concerned. But brief summary of what tail recursion is. So it's one where the final action of the function is the recursive call. So it's easiest to see it with examples. Generally, you would use something like an accumulator if you can, or equivalent to basically stop yourself having additional tasks to do once you return from the function that you're calling recursively. Why is this good? Well, why is the non-tail recursive bad? You basically have to go down all the way until you can actually return something. And then once you've returned, you then have to go through all the functions that you've just been through, so you finally get back to main. And if you're doing this a lot, you can get stack overflow, which people don't like. And then, yeah, it takes up significant memory as the number of iterations of your recursion increases. There must be a better way, which is tail recursion it's not it, because tail recursion trivially is exactly the same. The only difference is that when you get to the end, you're returning the same thing at every stack frame. But this means that we now have the opportunity to optimize that, and there's quite a few different options for that optimization. The main one of note is reusing the stack frame. And the reason you can do this is because you don't need anything left on your sum5 stack frame when you go back up the sum1 stack frame, because you're just returning the same value. So instead you can just blat over it and reuse the same thing, or you could pop it off and then add the other one afterwards. But the end result will be the same, because sum1 just needs to return 15. You can just return directly, which is great. You can also think of that as unwinding into a loop, or indeed your compiler could unwind it into a loop if it was very clever. And essentially, you can think of it as exactly mapping onto it as a loop. It would do exactly the same thing, and that wouldn't be the case if it was not a tail recursive function. And then there's this other method called trampolining, which you can do not as your compiler optimization, but you could just implement it yourself. And it has a not very nice definition, but trampoline is a loop that iteratively invokes func-returning functions, continuous parsing style, and a single trampoline suffices to express all transfers of a program. Program so expressed as trampoline, or in trampoline style, converting a program to the trampoline style as trampolining. Programmers can use trampoline functions to implement tail recursive calls in stack-oriented programming languages. And I guess it's that last sentence is the main one that matters, which is that you can use it to implement tail recursive function calls in stack-oriented programming languages, like the ones we're talking about here. And that func returning, so the definition of it is a subroutine used to inject additional calculation to another subroutine. Essentially, you're using lazy evaluation to execute the recursive calls later. So you're delaying it rather than queuing up everything on the stack. Probably shouldn't use those words together. And then returns a parameterless function used to delay the calculation. Is the simplest way to think of a func returning function. So the definition is kind of a bit terse, but conceptually it's fine. I found an example of it written in C. I did try rewriting this in C++. I didn't find it clearer. If anyone else wants to try rewriting this in C++, go for it. But this is kind of a nice example of how you would construct your trampolining environment in order to be able to execute your call without queuing up loads of things on the stack. This is how you would call it. So you would set up your factorial parameters. So in this case, using factorial as the example. And then your data is both the function itself and the parameters. You then set up your trampoline using that data, and then you can just get out the results. So what is it actually doing? Well, this trampoline function essentially is using a lot of callback and then doing it in a loop. So we have literally transformed it into a loop. And crucially, it's reusing the same data. These parameters are being used every time. And therefore, when you go into factorial, it doesn't have to replace these parameters, essentially blatting over them, but that's because it is actually a loop rather than doing anything clever with stack frames. So does C++ actually do these things? Well, yes, it does. If you take a really basic example, you kind of get yourself into trouble because C++ just optimizes everything. So even the non-tail recursive case, only at the lowest optimization level will you actually see this recursive call. As soon as you bump it up to O2, you lose it and everything's optimized away or inlined. So even though your tail recursive version, well, these are both a non-tail recursive version, but yeah, they both would see it optimized in any case. You can easily break that by doing something fairly innocuous, although you can see when you look at the assembly that it's not that innocuous, which is just adding in a string. And I'm not doing anything with it, I'm just passing it in, but it's having to construct one inside. And what that means is that when you're returning here, it's not actually tail recursive, because this isn't the last thing that happens. The last thing that happens is destroying the string. And so as a result, you do still end up, you know, even if you can see here, this is the recursive call. So even though it looks like a tail recursive function, it's not tail recursive. I mean, it is tail recursive, but it's not actually optimized, because it can't optimize it because it's not the final task. And so that's something that you have to be aware of when you're kind of relying on these optimizations, is actually checking that it's even happening at all. But yeah, taking a classic example, which does actually demonstrate the benefits of tail recursion, which is generating Fibonacci sequence. You can see this is the non-tail recursive case, which is probably a bit easier to read. But the downside is that we are calling this recursively, which means you could overflow the stack if you were doing this for very, very large values. Whereas in our tail recursive case, if we look around, we don't get that. We don't see that call going back. Now, I'm not very good at reading assembly. This is something I need to get better at. So I'm not sure which method it's actually using. I'm not sure whether it's reusing the stack here. I don't think it is. I think based on the fact that it says in a loop header, I think it's transformed it into a loop here, but don't quote me because I do not know. But the other thing to remember is that tail calls here, we were looking at recursion, but tail calls you can optimize not just in the form of recursion, but actually more generally. And they call these sibling calls. But what was quite cool is that when I pulled up an example of this, I was struggling to get it to not just inline things. And then I found out that you can disable inline functions. And when you do that, you actually see the tail calls, which is cool. And you can see this is a jump rather than a call. And it's conveniently told me what it is, which is very nice, very kind of them. So here you can see this isn't a recursive function, but we are getting tail call optimizations, which means we're not having to go all the way back through the stack to get back to main. We are actually able to just do one return from the final function in this nest of functions, and this is genuinely using tail call recursion. So I expect reusing the stack, and that's why it doesn't have to return from each of these points, which is quite cool. So the drawbacks. Debugging is the classic one. If you're debugging with optimizations on, then people are like, okay, but main doesn't call sum3. How did I get here? But if we're being totally honest, then you can't really debug optimized C++ code very easily anyway. So if you've got optimizations on, you kind of expect strange things to happen because compilers are crazy. And then recognizing cases where it doesn't apply so that you don't end up in Stack Overflow hell. It's always devastating. And then, so yeah, the main cause of this was having a look at what Rust does. So taking one example, you can see that yes, it does indeed optimize it. So you can see the non-tail recursive case, you end up, and it's not using a call, but this is what we're looking for in terms of it is a recursive call, even if it's not exactly the same. Whereas here you can see it's not doing any of those calls anywhere. Definitely optimized further. It's not the easiest to read, but it basically is an improvement. So who said that it didn't? Well, it kind of goes back in the history of Rust. You know, does this happen? And then someone being very true to their word, the creator of Rust, I never actually confirmed that they were the creator of Rust, someone very important in the Rust world, basically said, no, it doesn't support tail call optimization, and they have a long-standing bug. But because that it kind of did support tail call recursion, so it's a little bit confusing, but kind of summarized why it doesn't in various cases. So first of all, saying, look, I love tail call optimization. This is not something I wanted to do, but plays badly with deterministic destruction, which is what we saw in that string case, where even though we weren't using the string, it didn't know that it could destroy it earlier. And that's why just by adding in one variable of a string being constructed, or, you know, if you decided to take your array and then put it into a vector so that you could do something that was easier on a vector, just locally, you would then completely break your tail recursion, because the vector would then have to be destructed at the end. And in the case of the string, it's not there, it was an empty string anyway, so it doesn't even necessarily have to allocate anything because of the strong string optimization, but even that doesn't help you. So yeah, and then other examples. They play badly with assumptions in C tools. Now, I couldn't get to the bottom of what exactly he meant by this. If anyone knows, then yeah, let me know, or do a very short talk on it. And then the other reason is that you can do it in a different way. So you can convert things into loops, and you know, this is absolutely fine. It's fast, and it's easy to do as well. So you know, you don't have to use proper tail calls in order to get the same effect. And there was a little asterisk saying, you know, switch in loop state machine is indirect dispatch, so will likely run slower than one encoded by tail call state to state. So I think based on this, it makes me think that those optimizations that we saw for the tail recursive case for the Rust one weren't doing true tail recursion that we saw in the, you know, the tail call list of call A, call B, call C, call D. Those were proper tail calls, whereas this other one I think was probably just unwinding it into a loop, which it could do without having to implement proper tail recursion, which would involve reusing the stack. So the final one, so we talked about doing tail calls everywhere, across all programs, kind of across all platforms. The tail call optimization, I don't know if you've seen that. Tail call optimization is architecture specific. I did start having a look at the LLVM cookbook, but I cannot comment on it because the examples did not make sense to me. But they may do one day, and if they ever do, and I ever have anything to say on them, then I will be sure to let you know. But the general conclusion I came to is that when people were talking about Rust not having tail recursion, what they meant was proper tail recursion, the real deal, rather than just the simple optimized cases that C++ has. Wanted, you know, potentially full tail recursion optimizations everywhere, so that you didn't have to worry about, you know, these Stack Overflow cases that could be optimized away. And there are various languages that do this, none of which I have written. So there were kind of suggestions for how you could do this in Rust. So how you could have proper tail recursion, so that you could say, I've written this function, I think it's tail recursive, but I want to know it's tail recursive. And so you could replace the return keyword with a become keyword, which would then mean that you would know if this compiles, this is doing, you know, a tail recursion optimization. And if it doesn't compile, well, you know, you could have gotten Stack Overflow, so you've just been saved from a lot of heartache. And there's, you know, descriptions of it. There's a rough implementation which doesn't work, but it hasn't been successfully created. This is not a keyword in the Rust language. Maybe it still will be one day, but it's hard to write something like this because of the deterministic destructors and all sorts of edge cases that I couldn't possibly comprehend. But yeah, this is the general definition of how they would want it to work if it were to work. This would be the proper tail recursion. And like I say, it's still an open issue, and yeah, guaranteed tail call optimization. People still want this. They bring it up. You know, this person says it's been dead for a while, but I'd like to propose thinking about it again, trying to kind of nudge people in that direction. And there are kind of various reasons why they haven't done it. So some people said, well, LLVM didn't have it before, but now that it does, so could we use that better? There's this thing called a must tail marker in LLVM, which means given certain conditions, you can guarantee this will, I promise I will use tail recursion here, and which is something that it could definitely use. But what we're kind of moving into is the world of functional programming. So it made me want to learn a bit more about functional programming and understand why when people were, asking these questions, does it have tail call optimization? They were kind of taking it one step further, where it's kind of an expectation in some languages in a way that it's not in languages like C++. But Rust is kind of straddling a kind of gap in between, where some people write Rust in a very functional way and some people write it in a very object-oriented way. And it's a nice hybrid. And this tail call optimization is kind of a sticking point for some users. So yeah, really enjoyed it. But it does not have it. The become keyword does not exist. If anyone writes an implementation for the become keyword, then please let us know on the Discord channel that we have created for the Rust and C++ Cardiff, or anything else. I put QR codes so that people could join it more easily. Yeah, that's the end of my talk on Recursion, but just about Discord. So we created it because there's not really an easy communications for the Rust and C++ people who come to these meetups and might want to, send interesting things they read or be told when the next meetup is. And this seemed like the easiest communication channel. So we created one. And yeah, check it out if you want to be involved in conversations. I say, does anyone have any questions? But I won't promise I'll be able to answer any questions. Try.
It is a nice topic. Yeah, it takes time to find a nice topic, and that one is.
And there's further you could take it as well. Like I would like to dig into the assembly a bit more and understand a bit more about what's actually happening. And especially the tail call case, because that's something which happens everywhere through code bases. The non-recursive case, loads of functions will behave like that. And that optimization is just kind of quietly going on under our noses. The tail recursive case, you kind of rely on it, whereas in those cases, it's just more of a nice to have, but it does make a huge difference.
Yeah.
Right, I think no questions. So, Krzysztof, I'll pass over to you.
Yeah, I don't have much to say, I guess. I really enjoyed it, but I always do. So, yeah, not sure about you, but I'm constrained with time at the moment because I need to put my boy, get him to sleep. So I will have to leave at the moment. But as I said, I did enjoy it, and hopefully we'll get another one sooner, maybe.
Yeah, we've got a talk prepared now, haven't we? So
yeah. So what? Friday?
Yeah, so you mentioned that this become keyword it's not part of the language, but they're thinking about doing it.
It's a suggested implementation for getting proper tail call optimization into Rust, without causing massive confusion and turmoil. So basically getting you to actually say you want tail recursion. The problem is the implementation for it doesn't quite work yet. So I think it works in some cases, but probably not all.
It's kind of like from what you said, right? So let's put become, and if it compiles, then we're finding that is doing the tail recursion, right? So yeah. It's like with a little bit with the const expr functions. If it compiles, there is not undefined behavior.
Yeah. No, I guess to some extent, perhaps one could write a C++ trampoline library that sort of like that. Like you give it a lambda or something, and it will, in such a way that ensures that it won't really let the lambda itself will not need to be recursive, but the trampoline mechanism will call it time after time, but within its own stack frame. So if you manage to compile it without, it gives you the right results, then you can be sure that whatever input you give it, it won't generate a stack overflow. So maybe.
Yeah, so trampolining saves you from stack overflow, and you can definitely do that in most languages, but it doesn't necessarily have all the performance and benefits that the other one does. And I think it, what's the rationale for why it doesn't?
Yeah, there was also mentioned there in the quotes that you put around the switch statements within loops, or like a loop of switch statements. I think I've seen this like idiom before of running a while loop within a switch statement, where basically in each iteration you jump to a different case. And I think it's also a way to get good performance for this type of thing.
Yeah, big fancy state machine to.
Yeah, and again, it's
do the
very hard
optimization.
to look at and reason about, and yeah, so it's tough.
Yeah, that's the big thing, is being able to write something recursively without, and still have it work. Being aware that, you need these optimizations, because without them, you end up with Stack Overflow. But if you try to write it yourself as a loop, you lose so much readability.
Yeah, tricky stuff. Thank you.
Shall we call it an evening?
Yeah.
Anyone?
Yeah, thanks a lot for your time. By the way, if you have any like both questions or comments for me, also, any feedback regarding the talk, both content and as well as technical feedback, be happy to hear about it. You can send me an email or whatever, just so that my talk next week will be better. So thanks.
Do you have maybe Twitter account?
No, I do not. All right. Sorry. No, but So, but I put my Gmail in here, and the link that I put to the slides also is to my Gmail thing. So.
Thank you very much. It was a pleasure, and hopefully to see you soon.
Yeah.
Yeah, we'll see you in a week when we see you do your talk.
Be happy to join. So thanks a lot.
Thanks.
Thank you, guys.
See you, everyone.
Yeah. Have a good night then.
Yeah.
Oh.
Yes, guys.
All right.
You can stop talking now.
do you know repository for Richard? Like what he's.
I can find out. I can message him and then post it on the.
All right. Awesome.
So don't worry. And yeah, if anyone who was here wants to do a talk next time, always looking for new topics. So yeah, please. It's nice just to hear people talk about things. So.
Definitely. Right.
All right. See you next
time.
Cool.
Enjoy, guys. Bye-bye. Thanks.
Bye.